Hello and welcome to Cerulean Stream number 20. We've just launched 1.3.0 today, so really excited to talk to you about some of the stuff that's gone into that release. And I'm joined here by Farhan and Emmanuel. They've been working on some of the core features in this release that we'll be talking about and looking at today. So Farhan, Emmanuel, welcome. Great to have you here.
Hello.
Great to be here.
Awesome. So where do we start? This is a, as everyone knows, this is a regular release. We're doing these on the second Tuesday of every month. So 1.4 will be coming out into beta next week, and then launching in a month's time. Two of the big features in 1.3.0 that are experimental. These are introducing these features into this version in order to play around with these, and then we'll be stabilizing these over time as we get feedback from users. Two of those big features are CeruleKV, which is our own embedded key value store storage engine now, and the introduction of vector search using approximate nearest neighbor. So some of you know this out in the wider world as HNSW. It's effectively the ability to retrieve matching vectors in a vector database, let's say, or a vector index, to retrieve matching vectors, but not necessarily fully accurate. So as long as it has a 75, an 80, and 90% accuracy, and that depends on the implementation and the index and the speed with which you want the retrieval. But these are two really great features in CeruleDB, and we can't wait to talk about them today. So I'm going to bring Farhan up to begin with, just to chat about CeruleKV. I think let me just bring up the questions and let's see. So Karim Lalani, great to have you here. Hopefully you're enjoying the stream so far, but we've got some really cool stuff we're talking about over the course of this next 25-30 minutes. So yeah, hopefully if you've got any questions at all, then put them in the chat, whether that's in a comment section on YouTube or on LinkedIn, and we'll answer them as best we can as well. So yeah, Farhan, what is CeruleKV?
Nice question. So CeruleKV is our in-house key value store, which we have built in Rust. Over this period of more than 1 year, we have realized, using different key value store, what exactly our needs are. And in terms of querying, writing data, and then also building up our cloud services, right? So this is the first step. It's an embedded database. It is meant currently for single node environments. It is asset compliant, so it's not just an in-memory key value store. It has persistence. And the interesting part is it also has a bunch of isolation levels which you can choose from. Most of the existing databases enforce either serializable isolation level, but we have snapshot isolation level also. So it could make it easy for other users who want to have a store where the readers don't block writers and vice versa. And it's also exciting because this lays foundation for our distributed key value stores, which we are going to build. Currently, it is an experimental feature. We are trying to battle test it internally, and post that, we look forward to launching it.
Awesome. So just to go back on some of those points, this is our own embedded key value store. It will effectively, in the long term, it will replace RocksDB or SpeedDB as storage engines in CeruleDB. But the main difference is it's completely built in Rust. It's 100% Rust code, and that means that we'll be able to build and compile this into any environment where we need to, whether that's the Python client, the Node.js client, a C library, or anything like that. We're not having to rely on C bindings to do that, which makes it far better from a development perspective, from a build perspective, from a compilation perspective, and then also eventually a performance and a runtime perspective as well. So really, really exciting. I think the questions we're going to have from the community. Well, here we go. Got a couple of questions already. So first of all, Daniel, buenos dias. Great to have you here. Mika Eriksson, konnichiwa. Great to have you here as well. We've got Alex Privet. Great to have you here. I presume you're joining I have no idea where you're joining from, but great to have you here anyway. We've got somebody here from the UK as well, looking to learn Rust. So we've got a question here about what is the difference for remove table and remove table if it exists in case there is no such table? So we'll get onto that in a little bit as well, Alex. That's a good question. We've got some schema improvements in this release as well. So we'll be getting onto that. One of the big questions from users, I guess, we have on our Discord and on our blog posts and everything like that is, why Surreal KV? Why not RocksDB and LevelDB? LevelDB and CockroachDB has Pebble. There are lots of different alternatives out there. Why KV? Rust. That's the benefit of building our own store and the function.
Yeah. Can you hear me clearly, just in case? Because okay. So it's an interesting question. Why build our own key value store when there are already so many existing ones? So every key value store is built for a specific purpose. If you take RocksDB, any LSM-based engine, it's built for efficient writes, right? And then if you take B-tree-based key value stores, and those are built for efficient reads, but they'll be slower at writes. So we wanted somewhere in the middle so that we can actually be efficient in reads and writes. And of course, as per Rum conjecture, you cannot satisfy everything as such. But this is the area which we want to line to have efficient reads. And basically in Surreal KV, we use something called immutable radix, adaptive radix tries. So it makes the keys compress in memory, so it doesn't bloat up your memory as such. And writes are just append only. So it's a mix of both reads and writes. So I think that is the exciting part for Surreal KV.
The other important difference as we look at improving the read performance is the ability to actually read different versions of keys, and therefore that will offer us benefits in terms of SurrealDB. How does the radix try, Farhan, enable us to do that, and why a different data structure? Everybody has data structure. Everyone has heard about the B tree. Why something different?
So radix tries, and in general, the specific one which we are using is adaptive radix tries. It's known for its path compression. And the other part is it's not just an adaptive radix try, it's a copy on write adaptive radix try. So any copy on write structure by default gives you the ability to actually create snapshots easily. That's why if you want to create a database which supports snapshot isolation, usually what other databases do is that they do have copy and write structures, but they also have to depend on disk to create these individual snapshots. But with this version adaptive radix try, we get the ability to also create snapshots and in memory, which has very low overhead. And through that, I think one of the use cases for us was also not to have one writer only, right? One of few key value stores which we checked, we were blocked with having only one writer. And with the scale that we had, it was a blocker for us. So the way Surreal KV is implemented using this radix try is that you can have multiple writers and readers at the same time, and conflict detection happens using normal MVCC techniques.
Awesome. So effectively, this is an exact replacement for RocksDB in terms of the behavior that you get. So the ability to have multiple writers, multiple readers. Those conflicts happen at the time of commit of data change or transaction. And therefore, as we go forward, this will be something which will compete in terms of performance with RocksDB as well. Fine, just to kind of give a general overview of where we're at now. Obviously, stability and lots of testing and understanding that this is a safe file storage engine and file format as we go forward. But where do we stand in terms of as an alternative to RocksDB right now?
I'd say that we have a working mode right now. The thing which we are testing right now under SurrealDB by integrating Surreal KV is about the stability to handle, and mostly the tests are on durability, right? What happens when your machine restarts? Do you get your data, does it get lost or not? So it's more about testing on the durability aspect. you can actually start using Serial KV and just start testing it out about if you want to check out the performance in terms of reads and writes. It's comparable to RocksDB. Obviously, RocksDB has been built over a long period of time, and again, there's no direct comparison with it because it's an LSM store, right? It's built for a different purpose. So hopefully over the next month, we would want to test the durability aspect of it before we release it because that's the paramount thing for us. Performance-wise, we are there. More improvements will come with time, but durability is what we'll be looking at over the next month.
Awesome. So for those viewers or listeners who haven't seen our blog post, there's an awesome article written by Farhan on the versioned adaptive radix trie. So VART is what it's called, and that is the data structure used internally under the hood. We're also working on a log structured merge tree storage functionality as well. So the ability to have different characteristics around the data that is stored. So whether that's better writes or better reads, and really, as Farhan mentioned, you can't optimize for both. You can't have a perfect system that is suited for every single environment. So for us, versioned temporal queries is a route we want to go down in order to support better analytical operations in SerialDB, and therefore the ability to read over multiple different versions of data is an important characteristic of the underlying storage engine, which is not something we'll ever be able to offer on RocksDB or the other storage engines we have. So if you've got questions around Serial KV or the adaptive radix trie, then jump into our Discord, jump into our GitHub. We've got an open source repository, Serial KV, on our SerialDB organization, where you can jump in and see the code, see the pull requests that Farhan's working on a daily basis. We've got no other questions in the chat right now on Serial KV, but definitely a lot of people excited about it. Coldino, great to see you here from our Discord, and from GitHub. Yeah, look, it's exciting. Serial KV is it's going to be an important differentiator between SerialDB and the other databases. And not only that, it's going to enable us to innovate quickly and push the boundaries of kind of what you can do inside the database, but also inside our client SDKs as well. So it's really exciting stuff. I've got a question here from Alex K. So what is the difference between remove table and remove table if exists, in case there is no such table? So beforehand, if you did remove table and it didn't exist, it would cause an error. And that's the same thing with define table. So there were slight inconsistencies in the behavior if you were defining a table or removing a table, and there was no such thing as if exists or if not exists. So for some statements it would error, for some statements it wouldn't. This is effectively a much better way of ensuring that you know the response you want to get. So if you're running a define statement and you want to completely overwrite it, then you just run that define statement. But you can now say define statement if not exists, and then it will error if that define statement already exists or not. Same thing for remove. So it's ensuring that there's a consistency between all of the different define statements, and then also in your application, you can run a whole SerialQL import script or a whole set of statements and understand that they are going to work without errors or error if you want to. So it's really about consistency rather than the change of any major behavior, if that makes sense. Fine, while we've got you here, we've got a question from Coldino here. Will Serial KV lead to a new history query syntax?
Right. Actually, I think I forgot to stress on the part about the version part in the adaptive radix trie, right? Usually what happens is when you want to store history for particular keys, let's say in RocksDB or anywhere else, what you do is you append it to the key and then you write it to the storage, right? And that becomes a problem because then you have to read all the keys and then the timestamp is appended at the end. But the version part in adaptive radix trie, what the version part means is that the different change set for a particular key, whatever is being changed, is stored on the index itself. So yes, as per the API, you will be able to query for a particular key and be like, okay, what is the history of this key? What is the change set? What has happened over a period of time? And eventually, I think in Serial DB, we will look forward to adding it.
Yeah, awesome. So it's that, Claudine, that's definitely functionality we want to have in there. And the storage engine is almost the first step that we want to get there on that journey. So definitely more we need to do in terms of stabilization and performance on Serial KV. Albeit we've been running some benchmarking internally, and we're already pretty excited about what it can achieve. But yeah, absolutely. We'll then be adding slightly new history query syntax. So I mean, there's lots of different papers out there for this, temporal querying and temporal query logic and things like that. But we've got some opinions internally about how you may be able to run historical data or historical querying across a table or across linked and related and records and graph records as well. So definitely this is on our immediate roadmap and something we're looking forward to kind of announcing in due course. And Claudine, we've got a follow-up question here. It's going to be interesting to see how that's handled in the language when storage engines differ. Absolutely. There will be some things that some storage engines won't be able to handle. Version temporal queries on a key value store that isn't designed to store or hold version data is not going to be efficient. So it's not going to be something we support. So gradually over the next few months to years, we will be pushing the default engine towards Serial KV, and that will have better support for more of the functionality in SerialDB. But at the moment, RocksDB is the default storage engine, and it's got great performance. It's battle tested out there in the wild. So that's definitely something we're supporting right now, and obviously, this is something that is going to change with time as we introduce more functionality that is specifically benefiting from Serial KV. Awesome. Fine, thank you. We'll keep you around just in case we've got any other questions about Serial KV. We've got a question here from Glucon, which is so Glucon knows that Serial is implementing HNSW. Obviously, that's you can see the pull requests on that into our repository. Will there be an option IVF flat? So I'm not sure what that means, but I'll relay that to Emmanuel.
Yeah, hi. IVF flat is an alternative algorithm, right, for approximate neighbor search. So no, we don't have this plan yet, but we are happy to have a suggestion. I mean, if you have some input to give us, and so we are willing to implement many different algorithm approach for vector search, and IVF flat is one of the options. But for now, it's not yet planned.
And you, just to for our listeners right now, Emmanuel, what algorithms do we have already in development?
Yeah, so related to vector search, right?
Yeah.
Yeah.
Can I
share my screen? Because
go for it.
I'm going to do that. Okay, so I have to reconnect.
Cool.
So give me 1 minute.
Okay, brilliant. So while Emmanuel is refreshing his page in order to do screen sharing, this is all about getting some fundamental. This release is all about getting some fundamental core functionality in. So Serial KV, the start of slight changes to the query language for HNSW indexing and vector search, and along with that, just like changes to the algorithms. So Emmanuel will talk more about that in a few minutes. But some also, as you noticed, some improvements to how the schema is being handled in SerialDB. So this is something we want to improve gradually over time, get that consistency, get that performance, and it's more about expectations about how it should work from a developer point of view. So this is something we're working on. Define and remove if exists, or if not exists was one step in that direction, and we've got other functionality coming soon. Here, Emmanuel's back, so hopefully we can share screens this time round.
Okay.
release.
Can you hear me? Can you see my screen?
Yeah.
Yeah, brilliant. Um, so quickly, I wanted to make to showcase a little bit what we have now in terms of vector search capabilities. The first thing is that vectors can be easily inserted in a Siri database for edges, right? So if you want to create to put embeddings in a database, you just use this syntax, which is an array of numbers. So I'm going just to do that. Yeah, I have to connect. It's connecting. Okay, so while it's reconnecting, the first thing that we have implemented for vector search was the M3 implementation, the M3 index. So what is interesting with the M3 is that it's an index that allows to make an exact nearest neighborhood search. So you have the right vector that are returns. It's pretty easy to do, right? So, you create an index as usual. The type is M3. You give the dimension, and you have different possible distance that are supported. So actually, the distance that are supported for M3 are Euclidean, Manhattan, Cosine, Hamming, and Minkowski. If some of you may have experienced on release 1 to 1.1, Cosine disappeared. So the thing with vector search is still what we call an experimental feature. So we make some benchmark in terms of performances, accuracy, and especially for M3, the challenge was handling deletion. So deletion is now working well. At some point, it was not working well with cosine distance, so it's fixed. And it has been restored in 1.2.2. So this is M3. There is another thing that is maybe not known, is that we have also a brute force implementation. So this is what I wanted to show. The brute force implementation. So once you have points in a table, you can directly make a query. You don't have to create an index. And the syntax is pretty simple. So we have this operator called KNN, and then you give the distance and which kind of distance you want to have the nearest point off, right? So the interesting with brute force is that you don't need an index. It's a little bit slow, but if you want to, it works pretty well if you are in memory. If the size of the table is small enough, and more interesting, you have all those distance available: Chebyshev, Cosine, Euclidean, Hamming, Jacquard, Manhattan, Minkowski, and Pearson. So all of those are available, and it's pretty useful if you want to check the accuracy of your model. The syntax is really simple. Operator, we talk about it. We also have those set of functions where if you want to retrieve the distance, you can use any of these package of function, vector distance, and you give the name of the distance you want to get the calculation in the result. So I'm sorry, today it's not my demo day, so I cannot make a demo, mostly because the branch HNSW is still on development. It has been synchronized with main recently, and I cannot run it at this moment.
That's awesome. I mean, just to give an update to users, so you can already do brute force in the release. We're working on better indexing functionality. But in addition to that, we're working on benchmarking behind the scenes. We'll be releasing those benchmarking probably around the 1.4, 1.5 release point, so that users have a better understanding of how it might perform compared to dedicated vector indexing databases or vector indexing platforms out there. Bearing in mind that you also have to deal with duplication of data, network performance issues as well. So really exciting stuff. Obviously some massive additions to the Siril QR query language for vector search, and in a future stream we'll also be talking about general improvements to the parser, which has seen massive benefits in performance when we release the new experimental parser in version 2. So some really exciting stuff. Emmanuel, why vector indexes in SerialDB? What's the benefit?
So if you compare with many other implementations, for the first thing is that so we are not especially a vector AI database in the sense, or we are not just doing this, right? And we have made this demonstration as well with the full text search, where the full text search has been integrated in a way it's just another index in the indexes that SerialDB support. And then when you need to mix together a full text search, a search with matching keywords, and also you want to filter on another field, and maybe you want to make a group by, and maybe you want to make some analytics. In fact, you have all the power of the SerialQL language that is there together, and that let you mix those full text search as well with any other operator or clause. And the same thing for vector search. So for vector search, once you have your point in your database, you can mix them together. So first, you can imagine that you have a different set of model that live in your database, and sometimes you want to make comparisons. And in this case, you can clearly just add. You can just in your record add, I don't know, a version of your model. And sometimes the vector does not change from one model to the other, and change for some records. So you could easily say, look, make the key and search on the record that belongs to this model. So you can have 10 different models in your database live. They can even be updated. And you can still request them. And live, you can switch from one model to the other. So if you add the fact that if you use one of a distributed key value store, and HNSW, and this is where HNSW will be interesting, is that you can have millions of vectors, and HNSW is faster because approximative and works well for many models. And then you can mix together this filtering and this multi-instance of different models, and you can just use a SerialQL query and filter on different versions of the model. So this is where it's ending.
Yeah, that's exactly the point, and this has been said well in Alani. Great to have you here, Karim. Really excited about improvements to vector search, especially since it makes SerialDB a viable database to power AI retrieval augmented generation applications. I think the important point is, instead of just storing your vector and having to bring that, connect that vector back to your data in your core database, with SerialDB, you can store that vector right alongside your other data. So let's say that is the text. You want to store the text and you want to store the vector for that text, and then be able to index both. Maybe you index the text with full text search, maybe you index the vector with vector indexing, and then being able to retrieve it in the way you want to, while still linking your graph connections and any time series data you have in there as well. And that's where the real power comes from in SerialDB, being able to merge all of these different models together. And the performance will always be slightly different, right? Because you're storing vectors in a database that isn't just designed for vectors, but you don't have to think as a developer about the developer operations side of how to integrate multiple databases, the network, the performance associated with that as well. So yeah, it's a great point. Something we're really excited on as we work through it.
I would add one thing, Toby, if you let me. It's the fact that you can also easily update the vectors. So you can make operation on vectors in SerialDB. So it's not directly related to indexing, by the way. But you may store vector and decide to apply an operation on all those vectors. And that works pretty well. And so I'm not sure it's a use case that has been evaluated yet, but you can imagine using SerialDB as a way to build the model and update the model. I would not be surprised that will be effective, especially in memory, but also distributed if you have a large number of vectors. But something that we should investigate. It should be nice to have the feedback from the community about this. I mean, do you guys expect to update your model living in a SerialDB instance? Is something that you had to think about.
Yeah, we've got some big obviously improvements coming, performance improvements, functionality improvements, also some big plans which we're excited for announcing this year. I've got a question from Glucon here, which is, are you working on some working ranking algorithms like BM25 for the indexing vector search indexing engine?
That will happen. So that's the next step. So BM25 is there, right? It's already implemented for full text search. But yes, we would like to have as well. I mean, we are thinking about new features that will match. It could be text categorization, so things related to vector search in general, and how we can make that easily to integrate with vector search with SerialDB. So any feedback there, guys? If you have ideas, if you have some use cases that you want us to handle in a more ergonomic way or more easier way, we are really happy to listen to that, so we can put that in the roadmap and start implementing it. But definitely vector search, full text search are supposed to work well together. And even if you can today build a model somewhere and then put that in SerialDB and then make a vector search there and retrieve the code, of course, if we can make things easier by implementing some of the logic directly in SerialDB, it could be probably useful. So any use case, I'm happy to listen to them and see how we can implement them.
Amazing, yeah. And just to reiterate that, for any, if you want to chat to the community, then you can always jump on our Discord if you're not on there already. Alternatively, if you want to join and chat with people of the team on Twitter or have questions on Stack Overflow, we attempt to answer as many questions as possible across all the different areas where developers want to ask questions. But specifically, if you have feature requests or bug issues that you're kind of hitting in whilst testing out these features, then jump onto our GitHub and add feature requests or bugs there. We've got lots there to do with full text search and vector embedding indexing and indexing in general. So have a look through. If you can't find what you're looking for, then feel free to add one. I've got a question here from the community from Raymond. Will SerialKV make Serial easier to embed, maybe eventually leading to have offline sync capabilities? So it's an interesting question. Fine, I'll let you answer this.
Yeah, I think that was one of the primary purpose why we built it in Rust, because as it is, it was hard to compile RocksDB being written in a different language. Also, one thing to note is that the log is just a simple append-only log, right? So if you want to have sync capabilities, it also becomes very easy just to have a reader on the log, and that you can use it like a CDC mechanism to sync it. So yeah, it will help you in offline sync capabilities.
Yeah, definitely. And just to add to this, so Claudino, it's a good point. SerialKV probably could be built into WASM, but there's no real benefit to that, because ultimately, at the end of the day, if you want persistence in the browser, you have to use one of the browser offered APIs, and that really is just IndexedDB. So we already have the ability to write to IndexedDB. That's available in our SerialDB.wasm library. It's something we're looking to kind of improve upon and tie up. But yeah, SerialKV could be built into WASM. No real benefit there specifically. But if you're dealing with client-side devices that aren't a browser, if you're dealing with an iPhone, if you're dealing with an iPad or something that syncs, effectively it's not a browser application, but it does have client-side syncing to the cloud. And that is something that SerialKV could lead to in the future, absolutely. Got one final question, Fine, which is always a tricky one, right? Because it depends on whether you implement this in the SerialDB layer, on the disk layer. But we've got a question about a question from Vitor about will it include encryption? So last question here, at what level do you do encryption, and will SerialKV enable that in the future?
Maybe yes in future, but before that we have essential features to implement, like compaction to be compliant with GDPR and many other things. So maybe down the line, yes. And as Toby said, we're not yet sure where exactly we can implement it on SerialDB itself and then encrypt the keys. And then at the end of the day, SerialKV is a storage engine, right? It depends on how you want to actually write data to it. So down the line, yes, but not immediate future.
Yeah, and just to add to that, so RocksDB by default doesn't really have encryption in it. You can compile it with different plugins or different code points which have been created by the community. Effectively, though, you can also choose to encrypt the data you put into RocksDB or SerialKV, or vice versa. You can choose to encrypt that data at disk so that anything residing on the SSD drive or the hard drive that you're storing RocksDB on can be encrypted. So there are loads of different ways that you can encrypt data. All of them can be considered encryption at rest. SerialKV will definitely fit into, well, it can fit into all three of those. So being able to encrypt the actual pages of the data, sitting on an encryption at rest disk, and also potentially pushing data to SerialKV, which is encrypted in the first place. So bearing in mind each one of those affects performance, that is something we're looking at over the longer period. But as Farhan said, when you're dealing with version data and you store that data over time, you definitely have to think about compaction of that data, removal of anything which is which needs to be deleted over time, especially when you're dealing with requirements and compliance like GDPR, where you can't just hold on to data indefinitely. So yeah, it's a really good question, and something we'll be talking about more in the future. So there you go. 1.3.0 is out. Feel free to jump in, test it. SerialKV itself is available on the nightly, and we'll be testing this more internally. You can build it already in 1.3.0 if you want to and test that. As we iron out some of the bugs, we'll be releasing this along with benchmarking over the next few months in the actual product, and then it will be in version 2.0 by default, not the default store, but it'll be available there as well. We've got a question before we go about benchmarking. Raymond, I know official benchmarks aren't out yet, but just from your internal testing, what are the ballpark speed improvements you guys have been seeing? So there are definitely improvements on deletes when it comes to SerialKV. We're seeing roughly getting there on par with RocksDB in terms of selects, creates, and updates, but definite improvements on deletes already. This comes back to another point, which is we're actually not just implementing append only, we're also implementing LSM. So those will have different characteristics for reads and writes and deletes, and we'll be knowing more about the differences between that and what we can offer over the next coming months. There's also the addition of performance improvements in the SerialDB compute layer, which we're working on over the next release as well. So for version 1.4, we should see some better improvements there. A slight layer of caching and removal of unnecessary writes when it's not needed. So we've got some performance improvements across the board coming as well. And then version 2, some of you may have tested it already in the nightly. We've got a completely new parser. It has slightly different behavior because it's more easy to reason about certain ways of writing the language, but the parser is far quicker. So a lot of the performance issues in SerialDB are not really are not really due to the storage or anything like that. It's down to the parser, and that's something which in version 2 is going to be completely improved, and you can already test that out on the nightly version already. So we are working on benchmarking continuously as we build features and we test our code, and we will be releasing these for you to try out yourself. If you want to run these in the cloud, if you want to run these on an iOS device and test and compare, then you'll be able to do that. We'll be open sourcing all our benchmarking code in the future. So with that, it comes to the end of the stream. It's been great to have everyone here. Thanks for joining us, and if you've got any questions, then jump over onto GitHub, onto Discord, or wherever else you like to hang out. And if you've got any feature requests or issues, then do, as you're playing along with these features and around with these features, then do submit these. This is all about how we build a better product and how we learn. It's from the users who use us and the developers who build on top of us. So Emmanuel, Farhan, thank you. Some awesomely exciting functionality. I just can't wait till these are production ready. It's going to be exciting. So everyone, thanks for joining us, and see you all soon.